Hello, my name is Laura Devendorf, and I'm presenting this paper, Craftspeople as Technical Collaborators, on behalf of myself and my co-authors, Katya, Arquilla, Sandra Wirtanen, Allison Anderson, and Stephen Frost. I will apologize in advance for maybe some poorer than average video quality. This COVID time has been a little bit difficult for time management. But without further ado, I want to introduce this paper by situating it within HCI's discussion on craft and how we often, I think, are at the point where we're really acknowledging that the work of craftspeople, whether it's in pottery or whether you see software design as a kind of craft, is really increasingly relevant to technological innovation. But we talk less about the craftspeople being innovators in and of their own right or being technical. There still seems to be implicitly in some of the ways that we design or describe craft, this idea that craft is still sort of over there or of a different kind of caliber than what we're doing in HCI or in engineering. But that difference, minor as it may seem, does make quite a big difference in both political and practical senses. So in a political sense, we can't separate from histories of technology and craft that were largely exploitative. So like early electronics manufacturing, as Lisa Nakamura describes, being performed on Navajo reservations and really being framed as this kind of romantic native activity that they were drawn to without acknowledging the broader politics of the lack of opportunities for other kinds of work to be performed. This also comes up in Daniela Rosner's really wonderful book on critical fabulations and how a lot of the handwork and the manual work done by women in the early NASA missions was largely overlooked as sort of just manual, mere labor. In a more practical sense, we can kind of imagine most design projects happening in these various phases. And a lot of the ways that we're including craftspeople seem to be in these larger or later part of the stages. So we can integrate craftspeople to figure out what the needs of our system are. Say if we're designing a 3D printer with clay, we can integrate them in the look and feel prototyping. Say if we want our design to have a really richly crafted interface, or we might often include them in refining or testing a prototype as a kind of power user that helps us find new applications. But what this leaves out is this really interesting role that craftspeople can play if we consider them technical in these earlier ideation stages. So this project really set out to explore this question. So what are meaningful ways to engage craftspeople in mutually beneficial innovation? So what does it even mean for mutually beneficial collaboration to take place? What does that even look like? What are the risks and the gains for all the parties involved? And so with this question, Daniela and Brosner and I coordinated a workshop at the University of Colorado that really focused on how we could bring together engineers and craftspeople and local businesses and community organizations to think about collaborations. And the main finding from this event was that the most important thing for this kind of feeling of mutual benefit was coming together at the early stage. So not having someone come to you with an idea for you to make or participate on, but coming up with the idea genuinely together. And with that, we formulated a grant application to the Center for Craft, Creativity, and Design, now known as just the Center for Craft, to their materials-based research grant program that really envisioned a way that we might be able to bring in craftspeople, specifically weavers and fiber artists, into some of the research the lab was already doing in smart textiles. And so we did this massive call. It got a lot of attention, and we had 200 applications. most of which were very interesting craftspeople. And it goes to show that there was a lot of interest in collaborating in these more experimental ways. And through a long recruitment and application process, and with oversight of a residency board that we assembled of different experts in art and engineering, we selected Sandra. And you can read more about those processes in the full paper. But Sandra is a very lovely person and was a trained textile designer just coming out of Aalto University at the time and living in Helsinki. And so we offered her the residency, and she came to join us in the summer of 2019. And so based on that finding that we like to come up with these ideas together, we convened a lab meeting when Sandra first arrived to just really have an open-ended conversation about different things we might do together. And we had people from the lab there, but also people like Katya and Ali, who are from aerospace, and thinking a lot about these really interesting applications for spaceflight. And those applications really piqued Sandra's interest, and she expressed a desire to collaborate on that project with Katya, the PhD student leading the project at the time. And so Katya was specifically looking at remote sensing, specifically for things like spaceflight applications where you need to have a soft and comfortable form factor that's relaying really precise information. So what she needed was what is called a dry electrode. So something that can measure physiological signals on the skin and maintain good contact without having to be physically attached to the skin with any kind of gel or adhesive. And so that collaboration really started with Sandra's notes here, mostly written in Finnish, as with her file names and things, kind of thinking about the structure of where all the components are going to go. So really doing a kind of PCB design for a woven circuit. And we envisioned this, this wearable sensing system being a headband that's worn on the forehead with 2 electrodes at the forehead and 1 grounding electrode. And that would take EMG signals and route them to an Arduino, which could then be read. So it was a kind of first prototype for whether a dry electrode could work or not. And so this involved a lot of prototyping, specifically prototyping elastic structures that could hold the electrodes really close to the skin, and prototyping different multi-layered pocket structures to encase the electronics, but also to fill with padding to apply more pressure to the skin. We also experimented quite a bit with different material compositions that could wick away moisture so that the readings wouldn't be so highly variable. We experimented with different ways of routing traditional silicone-coated wires through the structure of a woven fabric. And this one's quite nice. It's a fully encased Arduino Mini with the programming board coming out of the side. That's fully encased in the textile itself and padded so it's comfortable against the skin. And so this design, this is a later stage design. One of the main challenges was it had to be really, really stretchy and also maintain good contact. So it took a lot of iterations to kind of come up with just the right configuration of materials and weave structures that could allow for these different behaviors. And here's a later photo of Katya and Sandra actually testing the headband. And here's a close-up of one of the earlier stage electrodes and how it looked and integrated into the headband itself. So one of the first findings from this process, and including a craftsperson in the ideation phase, was there was this broadening, especially for Katya and Ali, in terms of thinking about electrodes, from coming up with more traditional technological solutions to seeing new solutions just inherent in material and structure. So instead of maybe just applying a gel, thinking about how materials like wool and different structures and different pillowing kind of pockets can lead to new possible solutions that might not have been considered before, that the engineering team didn't necessarily know was possible. The second finding we had really came from a mistake on our part. And I think this one is pretty important. And so that's why I'm highlighting it in the talk. But we kind of had a sense we wanted to involve craftspeople in the early ideation. But when we were actually going through making our selections, we did a lot of culling of the list based on what we would think was their technical proficiency, based on prior work with coding or Arduinos or even parametric design. And we had this assumption that a collaborator in our space would necessarily have to know something about these technologies to be effective. But this really turned out not to be the case in our residency. And that actually, when we did follow-up interviews with Sandra about her experience, it ended up being a lot more important that we, the kind of more traditional engineering team, really understood that weaving was hard, and we had tried it for ourselves, and we could speak enough of the language of weaving to make for more interesting conversations about what would be possible, or just to even allow Sandra to take a lot of time on things, because we understood how hard and how much time it really took to kind of come up with a really robust elastic weave structure. And this wasn't just a benefit for us. In getting back to this idea of mutual benefit, this was seen as a benefit for Sandra as well. And so when we were doing these kind of follow-up interviews after the residency, she also expressed that this idea of being able to integrate material and design knowledge into a process from the beginning is rare, not just in HCI, but even in kind of textile-based research. And that there's an opportunity, a kind of rare opportunity for her to really be involved in that early visioning stage. That was really something that she saw valuable. And with that, I will say thank you so much. I very much encourage you to read the paper. There's a lot more details, not just about aspects of whether a collaborator is technical or not, but really about the structural nature of the collaboration and what we felt was fair in order to ensure a kind of equality between the artists and the engineers working in our space. So please do read the paper. We also are hosting a version on our lab webpage that's more of an exhibition catalog, and it contains a lot more of the details of the weave drafts and the kind of craft specifics if people are interested in that. But thank you for listening to my talk tonight, and I hope we will have a chance to meet at a conference in the future. And thank you again on behalf of all my co-authors.